Okay, so the fact that this section is called factor by grouping is a little bit misleading. If I had to rename the section, I would call it more of a introduction to factor by grouping, or even more accurate, a precursor to factor by grouping. So we're going to learn all of the pieces, and then in another section or two, we're going to actually get into kind of using all of them and then doing what people classically call factor by grouping. So for the first concept that you're going to need to know about is the greatest common factor. And so the greatest common factor is the biggest number and the largest factor of each variable that fits into, largest power that fits into every single term. So in this case, I have 10y plus 5. Well, there's no variable other than y in both terms, and it's only in one. So I can't pull out any variables, but I can pull out a factor. And so there are two factors for 1 and 10 that they share, or 5 and 10. They share 1 and they share 5. But greatest common factor is we want the biggest number that fits into both of them. So in that case, that's 5. And then what we do once we've identified that greatest common factor, or GCF, is we divide both terms by the GCF. We take the GCF and put it in front of a parentheses, and then what's left over inside the parentheses is what happens when we divide both terms by 5. So to walk through that, my GCF is 5. I'm going to throw that in front of my parentheses. 10y divided by 5 is 2y. And 5 divided by 5, a lot of people think that cancels and it goes away. That's incorrect. 5 divided by 5 is actually 1. And so that's what goes inside of my parentheses. Moving on to the next example. So in this case, we look at it and we see, okay, I have an x and a y. I don't have any variables in common. And then I have 2 and 3. And so technically, 1 is a factor. That's true. But generally, when 1 is the only factor, we say they actually don't carry any common factors. So in this case, the GCF is none. I would give you credit if you said 1. And so when that happens, we actually can't factor it any further. We could pull out a 1, sure, but then that's not really changing anything. That's almost kind of silly and pointless. So when we have no GCF, or just 1, we say that it does not factor and we don't go any further. So that can happen. What else can happen is maybe we have more than 2 terms. Maybe we have variables that are shared among different terms, and that's what's happening here in example 3. And so I look at every one of my terms, I see that 2 fits into 2, 4, and 6, and that there's no bigger number. So that is certainly the number that goes with my GCF. But I look at the terms and I see all of them have x's. And so I have x squared in the first term, x to the fourth in the second, x to the third in the third. And so the way that you can kind of keep track of the biggest factor that you can pull out of every term is it's almost kind of the opposite of what you would think. You would take the smallest power. And the reason for that is the smallest power of those variables, well, that fits into every single term, where if you say x to the fourth, well, the first term doesn't have 4 x's, so that doesn't really work. And so that's the kind of process when you're doing greatest common factors. You start looking at the numbers, and then you look at each kind of individual variable one by one and pick the smallest power that matches in all of them. And if they don't, if that variable isn't in every single term, then you just don't include it in your GCF. So in this case, our GCF is 2x squared. And then I didn't really write it out, but same process in example 1. I'm dividing each term by 2x squared, and I put a 2x squared in front of my parentheses. So 2x squared divided by 2x squared is 1. Negative 4x squared divided by 2x squared is negative 2x squared. It's very important to keep the sign. And then 6x cubed divided by 2x squared is 3x. Now, this is kind of the first, well, I guess it's the second building block in factor by grouping. But again, it's more of a very specialized case. And so sometimes when I have kind of a nice form of 4 terms, and we're going to talk about how to kind of build this in other cases. But now I have 4 terms here. I want to kind of tie the previous slide to factoring this type of problem. And I do so by grouping the first 2 terms and grouping the second 2 terms. And then I almost treat them as kind of individual problems. I look at the first 2 terms and say, okay, what fits into them? No numbers, but an x, I could pull out an x out of both terms. And then I look at the last 2 terms, and then there's no common variables, but I can pull a 3 out of both terms. And so that's exactly what I do. I pull out an x out of my first two terms, put an x in front of my parentheses. If I divide both terms by x, I'm left with y minus 3. And then I take my last two terms, divide both terms by 3, and so that put the 3 in front of the parentheses, and I'm left with y minus 3. And now, in order to find my two factors, what I do is one of my factors is going to be both terms in front of my parentheses. And then you may have noticed that actually what's inside the parentheses is exactly the same. And that's one of the cool checkpoints of factor by grouping, and even the real factor by grouping that we're going to see, is that if you're doing it correctly, that's going to happen every time. You're going to have something in front of some parentheses, and then those two parentheses are going to match. And so those are going to be my two factors. And so to write my final answer, what I do is I put a parentheses around the terms that I just underlined, x plus 3, and then I put another parentheses and put in y minus 3. And I only put it in once. I don't put it in twice. And so that's my factored form. And if you're wondering the why I only put it in once, go ahead and do the distributive property with the 3 and the distributive property with the 8, and you'll see that that actually ends up being the previous thing. But if you trust me, that's the process. You take what's in front of the two parentheses, that's one of your factors, and then whatever is matching is going to be your second factor, or your parentheses with two terms in them. So let's see it one more time. So again, first step is to rewrite it. Ooh, skipped ahead. First step is to put two parentheses around the first terms and two parentheses around the second term. And I guess I kind of skipped this step, but that's fine. I just visualize the parentheses in front of them. It's not super difficult. And so what we do is, looking at those first two terms, I have y cubed plus 5y squared. So again, no numbers fit into both of those, but a y squared does. So my first parentheses is going to look like a y squared times y plus 5. And now the last two terms, something kind of interesting happens. I have no common factors. So this is why I kind of emphasized in the last slide of, yeah, that technically doesn't factor, but it also contains the term 1 into both of them. And so when we're factoring by grouping, we have to pull something out. So it doesn't matter that it doesn't factor, I still have to put something in front of my parentheses. And so when that's the case, you just put a 1 in front of it. So this is what it's going to look like if I put a parentheses in front of my two terms, divide out a y squared, I'll be left with y squared times y plus 5. And then my last two terms on the previous step, there was no GCF. So I just pulled out a 1 and then put the two terms in parentheses. And now the process is exactly the same that we saw with the red lines on the left. I would look at the term in front of my y plus 5, in front of my y plus 5, I have y squared. And then in my second group, I have 1. And so that's one of my factors, y squared plus 1. And then my other factor is the thing that matches. And again, that's kind of our check. Both of those terms are matching. So my two factors are going to be y squared plus 1 and y plus 5. One more example. So in this case, I'm going to, you might want to do this on paper if you're taking notes. I'm going to put parentheses around those first two terms. And in this case, my GCF of those front two terms is x. So it'll be x times y plus 3. That's going to be my first grouping. Now look at the second grouping. I'm going to have a 2 and a 6. And so yes, the GCF absolutely is 2. That is correct. But if I pull out a 2 out of both of those terms, and so as far as what we've seen before, what that would leave us with is an x in front of both of my terms in the front, and a 2 in front of both of my terms in the last two terms. And so the issue here is that those two things inside the parentheses actually don't match. So that is a requisite of making sure that factor by grouping works, is that both of those things inside of the parentheses have to be exactly the same. But notice how they actually are super close to being the same. There's only one difference between the two. And the difference between the two is that one of them is positive and one of them is negative. So instead of pulling out an x and a 2, what we could do instead is still pull an x out of the first two terms, but then pull out a -2 out of the last two terms. And so that gets it so that both of my things inside my groups, or both of the things inside my parentheses, do end up matching. And now I can finish my factor by grouping. My first factor is going to be, or the first two terms of my parentheses are going to be x minus 2. It's what's in front of those matching parentheses. And then my second factor is going to be y plus 3. It's what's in the matching parentheses. And again, I only write them once.